Oh, I see. So, I mean, I could just make a direct west move. Yeah, what I would. But yeah. Oh, well, sorry. Um. So, I guess in my mind, it feels weird to have the ship make a reverse move directly. Yeah. 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 I get what you're saying. That's like the direction we'll be moving the ship. So, yeah, once we get deep enough. Yeah. Thanks, Rennie.
Thanks, Rennie. I don't think mine's working. Can you hear me now? How about now? Can you hear me now? How about now? Bueller, anyone?
Yep. All right. Okay. All right. We are.
Bueller, anyone?
We are on. It's the science party line. Welcome, everyone who might be following along on nautiluslive.org or our website. We have just finished launching the vehicles, and we are descending to an anticipated depth of about 2,600 meters. This is the third dive of our cruise here in Papahanaumokuakea Marine Monument. We're just getting situated here at the start of our dive.
Good afternoon, terrestrial bound sailors. Prepare yourself for an adventure. We're hoping to see high diversity communities here in the seamount. So we're gonna get some rocks and some corals and hopefully a bunch of wonderful surprises. Saw some sperm whales when we pulled up the Hercules yesterday. They came to visit and investigate.
I think that was still today.
Is it technically still today?
Yeah, I mean, I know it's hard. We run a weird schedule here on the ship.
You were just asleep.
Pretty sure that was still today.
Okay, well, as Emma will say, it was Blur's Day.
Yeah, Blur's Day.
This is the first I'm hearing of the sperm whales.
Really?
Yeah, no one told us.
They were viewed from the deck.
I definitely would have woken up for sperm whales. There's no question.
Okay, well, what you need to do is make a list. Let me know where your cabin is, and I am the one who will run through the ship, yelling, "Whale, whale!"
But no, not any whale.
Sperm whales.
Sperm whales specifically.
All right. Well, if you're going to be picky, I'm not sure I can.
Yeah, how long can we wait for the ID?
I will also wake up for blue whales.
Okay. Well, Andy got some great photos from the deck. So,
that's awesome.
If you want to ask him, you can
So not
check those
humpback
out.
whales, though. You won't wake up for those.
Well, you know, I guess we all have our standards, so that's all right. So if you're just joining in, welcome to this third dive of our cruise here. We are getting situated, and we will be with you here for the next 3.5 hours until we hand over watch. We expect this to be a 24-hour dive, diving to a depth of 2,600 meters. We are searching for lots of biological and geological observations And as folks are getting settled here, we'll try to go around and let you know who's in the control van here. If you are looking on channel 3 or sat feed 3 on the quad view, you can see us here in the control van on the Nautilus, descending to a depth. Yep, everybody wave. Everybody raise the roof, and they can see us raising the roof on the in the van. This is our watch's first opportunity to give a watch during the daylight hours. So we're the 12 to 4 watch, and we've been watching from midnight to 4 a.m. But on this dive, we're lucky enough to start it out. So,
Kimberly, I heard you were raising the roof during the whale sighting.
I was jumping up and down and squealing like a child. So yes, I in fact was raising the roof,
as it were.
Yeah. Yeah. All right, so we're going to go around and let you know who's here. If everybody could say your name and what you're doing, what your job is on this dive, and also what kind of whales would you be willing to get out of bed for? Steven, can you start us off?
Sure. My name's Steve. I'm in the video chair. And then what whales would I get out of? I'd probably get out of bed for most whales. I've seen a lot of dolphins, so probably dolphins don't wake me up. But other whales, I'd be happy to be woken up.
All right. Thanks so much.
And orcas, I know they're dolphins, but I'd wake me up for those too.
Okay,
Not that
all
we
right.
see any here.
I'm taking notes here, so, you know. Front row, can we hear your whale preferences and what you're working on this dive? I think you're not on SPL there, Dan.
My name's Dan. I'm sitting in the Argus chair, and at the moment I'm struggling with some very cryptic software I don't know how to work.
We believe in you.
I'm Gabby. I'm in the Herc seat, and I will wake up for, are narwhals dolphins?
That's what I was going to say.
I would wake up for narwhals, blue whales, right whales, gray whales, definitely orcas, for sure blue whales.
How about minke whales?
And
Yeah.
sperm.
They tend to be really small and fast moving. They don't stick around and show off very much.
Yeah, that's true.
And sperm whales too?
Definitely sperm whales.
Okay, okay.
For sure. That's my list.
Okay, thanks so much.
Hi, my name is Kate von Krusenstern, and I'm sitting in the navigator seat. I would like to be woken up for narwhales. I think my list is kind of short. Yeah, we'll start with that.
Okay, thanks so much. In the that's your front row, and in the back row here, our science row. We'll start down at the end with Sarah. Sarah, what about you? What's your whale tolerance level here? All whales all the time?
All whales all the time. Absolutely. Yep, wake me up for any of it. My name is Sarah Bremer, and I'm
You
sitting in
can
the
start the
data logger chair.
sonar again.
Amal Petroncio. I'm sharing the watch lead with Andrea today. I'm the expedition leader for this cruise, and all whales all the time, but I don't think you would have been successful after last night's watch. Even for an alien spacecraft, I needed that 5 hours.
Okay, all right, noted.
Did you hit run on that thing?
I am Andrea Balbus, geologist, and yeah, I'm pretty much all whales all the time as well. I would love to see more whales more of the time.
Yeah.
Yeah.
Yeah, I totally agree.
Quantity.
Quantity.
That's right.
I'm not ashamed.
No, yeah.
And I'm not embarrassed.
No, not embarrassed at all. I mean, like I said, jumping up and down and squealing like a child here.
Yes.
So my name is Kim Weaver. I'm sitting in the Science Communication Fellow seat. And so I am here to answer your questions on the website. If you have questions, you can go to nautiluslive.org and you can type questions to our team in the box there on our website. And we will get to them as we can here. And this is my first time on Nautilus. This is my third watch, so I feel like I'm learning every time, and I'm very excited to explore and see what we see. We never know what we might find down there. And if you are interested to know the depth and some other conditions where our ROVs are, you can find that information as well in the sidebar on nautiluslive.org. Right now, we are at a depth of about 380 meters, descending to 2,600 meters on our dive today.
And I want to propose a name for our group.
Oh, okay.
And I know that it has a geologic skew, but
Good.
you know, for our mini podcast that we put on here, I would like to propose that we name ourselves the Tectonic Talkers. Get it? Tectonic Talkers. Consonants. Oh, come on, give it up.
Good one.
Get it. I knew I could count on Gabby.
I'm here for you, Andrea.
Okay, well then throw out another name.
Okay.
I like tonic with lots of things.
Yes, well, there you go.
Absolutely.
The Tectonic Talkers. So we shake the earth with what we gotta say.
Okay.
Andrea, how long have you been holding this in?
She was probably dreaming about it while she was sleeping through those sperm whale sightings we had earlier.
Oh, gosh.
I missed him by 12
stop?
minutes. 12 minutes.
Yeah.
I think I woke up at 8 as well. No, I woke up at 8:45.
So what was really special
Brutal.
about the sperm whales that we saw today is they appeared when the ship was, you know.
Wait, Kim, did you see sperm whales today?
I did. Hey, you know, our listening public wants to know. I'm getting lots of questions to describe the incident.
Oh, really?
Yeah,
That's awesome. Oh, yeah, sorry I interrupted you.
No.
Go
I mean,
on.
The people must know. My loyal audience and our loyal audience wants to know. So the ship was stationary. We were recovering the ROVs at the time, and they appeared on one side of the ship, and then, you know, 3 minutes later, they were on the other side of the ship. There were at least 2 individuals, and then they passed over to the other side, and they did this several times, back and forth under the ship. And then as soon as Hercules was out of the water, they just swam directly away. It was like they were sticking around and seeing what was going on, and as soon as the ROVs were on deck again, they swam off to the horizon. So I'm not sure what they were thinking, but it was a super special moment for everyone here.
It's interesting that as soon as we stopped mapping, the whales came to visit.
Yeah, that's true too. We were on a dive, so we weren't doing any mapping.
Also, we hope and we hypothesize that we're going to see some greater diversity, some larger, more diverse communities here. And we hypothesize, or Chris Kelly hypothesized, that we will hit them around 2,100 to 2,400 meters. And that's why we're staying down this dive longer. Another thing that Chris Kelly is always on the hunt for a good sponge, but a sponge that he describes as good lately is one that has pigment. So if you see a sponge that has any color whatsoever, we want to really give that a good examination. Oh, and here he is right now.
Ah.
I was just telling them that...
summoned him.
I was just telling them you want a sponge with color.
Yeah, so we don't have video of the sperm whale encounter. It was on the surface. It was not filmed by our ROVs. So we do have some still photos that just we've taken with our personal cameras, but we did not get video from the ROVs.
You said Andy has the good stills?
Yeah. So we know they're out there, friends.
Kim, you know where the binoculars are on board?
No, but I know where everyone's cabin is, so I know who to wake up now for which whales, so.
Well, in the lounge, right on the left on the bookshelf there's 2 sets of binoculars.
Okay, noted.
Thank you. I appreciate it. I could just talk away. I was talking about you and your sponges. I wish a whale would just approach.
So for those of you just joining us, we are diving in Papahanaumokuakea Marine Monument. It's west of the Hawaiian Islands. And we will be here for a couple of weeks. This is our third dive. The name of this cruise is Lu'u'ae Ahiki Ika Papaku. This is the name that was given to this cruise by the cultural working group that helps to manage the monument. And this name means dive and come up until you reach the ocean floor. So that's what we're doing. We have a total of 14 dives planned for this cruise. And some of these dives, so far, we've had 12-hour dives. We're going to hope to push for a longer dive this time. And we have several scientists on board, as well as scientists joining us from shore over our science chat, as well as our live chat that you can participate in, which is on our website, nautiluslive.org. I see quite a few questions coming in there. So thanks for those questions. Keep them coming. We have a question coming here is, how do you remember the pronunciation of Pmnm? Well, we practiced, and we have excellent teachers here on board who are experts in the Hawaiian language and culture. And the thing for me that really helped me to remember it was to learn the meaning behind it. If it's just a bunch of meaningless syllables strung together, it's very hard for me to remember. But once we learned what each part means, it was really nice. And you're getting some support for your watch name of the
Tectonic Talkers.
Tectonic Talkers, yeah.
See that?
The people are liking that.
There's some geniuses out there in support of the Tectonic Talkers. That's a name for people who have revolutionary things to share, and we have revolutionary things to share about our wonderful planet Earth.
Might you call these earth-shattering things?
Wow.
That's a good one.
Beautiful.
We're on a roll, what? We're on a roll, what?
That's right. They don't call me the pun master general for nothing. We got quite a few folks tuning in live, so welcome everyone. We got people from US, Russia, Italy. Welcome Australia. I have no idea what time it is there, but welcome.
Oi, oi.
Oi, oi.
Got Germany on the line here, Italy. So thanks so much for joining in. Oh, Canada, hello, hello.
Hey.
Hey, how's it going, eh? This
We saw quite a few manganese nodules on the southern side of Ha'aeo last night, and so it'll be interesting to see what we've got something similar on the north side, or is it prefer a certain side of the seamount? That'll be interesting.
Yeah, so Emil, how far are we from our last dive site?
It was a short transit. Let's see, only about 15 nautical miles, I think.
Yeah, so we were diving last night on this same seamount.
Actually, Nav could probably correct me if you have time to zoom out.
Yeah, give me 1 second. What was the question?
The distance from our previous dive site.
Oh, yeah.
So did we crack any of those manganese nodules open? And
nah, we'll let
yeah, I think Beth takes a
USGS.
while. Yeah, and those are special rocks for Kira, who studies manganese crust and its growth rate and its chemical composition. So I'm sure she will be thrilled to get a bucket full of manganese nodules.
Little deep sea M&Ms.
Yeah.
They're resting
Hard
quietly
candy
in the
shell.
Uh-huh.
I'm pretty sure we've been promised a shark tooth on the inside of every one, right?
Oh, yeah. That's what I heard.
So we're about 16, 17 nautical miles north of our dive last night.
All right.
Fantastic. And this is on a named seamount. So this is a mountain that is completely submerged in an extinct volcano. And the name of this seamount is hhmm Seamount. I am not 100% sure of the meaning of that, but I got some indication from our cultural representatives on board that that might mean proud.
Oh.
So, yeah.
Yeah, and this is a guyot, isn't it not? Emma
Yes.
Yeah, so for our wonderful terrestrial-based explorers, guyot is a underwater volcano that has a flat top structure. And what that indicates to us is that that volcano was once breached the surface and was subaerial. And as it subsides and gets away from a hot spot or no longer has addition from magma, at some point the wave action starts to work on it and coral starts to build up as it subsides, and it creates a flat top. And that flat top is what we call a guyot, and it indicates to us that that volcano was once large enough to breach the surface. So it tells us something about the volume of magma that was associated with the event of formation of that volcanic structure.
You'll sometimes see marine terraces descending down from the summit, carved over time through as sea level changes with the ice ages.
Right, and if we were to travel on to the summit, you would see carbonate platforms that are the relics and the basically the old carbonate reefs that were forming at sea level as the seamount was subsiding. So the geomorphic structure in itself gives us a lot of information.
What's the spelling of guyot?
G-U-Y-O-T, and I'm the worst speller of all time.
I would not have guessed that.
So Admiral Harry Hess during World War II was from Princeton professor who was already in the Navy Reserves when the war started. He was eventually ended up in the Pacific, and while the ship he was commanding was transiting from island to island, they left that photometer running and mapped hundreds of guyots, which he named after the founder of the geological building at Princeton University. The namesake of that building.
Yeah, very nice.
And he'd also looked at submarine trenches.
Mm-hmm.
This is pre-plate tectonics.
Yeah.
But when he heard a presentation by Bruce Heesen at Princeton in '57, he said, "You have shaken the foundations of geology." And he went back and looked at his guyots and trenches and published a paper in '62 on seafloor spreading.
Yeah. And it's around that time, too, was the birth of geochronology with potassium-argon dating and being able to show the stripes on the seafloor that are associated with magnetic reversals have a time series component, so that could further support the hypothesis of plate tectonics.
I should say that Bruce's brief at Princeton was on the Mid-Atlantic Rift Valley and the plotting that Marie Tharp had done for him to piece together a picture of the Atlantic seafloor. And it was heresy at the time to believe in plate tectonics or continental drift at the time.
It was heresy during that time to think of plate tectonics, and it was heresy at the time, at some point, that mantle plumes actually formed chains of islands on the seafloor. But luckily our technology advances so we can test these hypotheses. And once we test them robustly over a long period of time and they still stand, we now become more comfortable for them as a general understanding of Earth processes through geologic time. Something that makes our planet really unique is that we're tectonically active. We have an active core that creates geomagnetic reversals and anomalies. and we're continuously have volcanic and tectonic activity.
I don't recall it. Do you know if the Canary Islands are on a hot spot? I believe they might be.
I think they are,
the
yes.
Azores are.
Yeah.
It's been a good year for volcanic activity.
Yeah.
Well, good for some, bad for others.
Yeah. So climate scientists have known for a long time that the Earth's climate system is intimately associated with orbital forcing parameters. So the way that the Earth moves around the sun, its distance from the sun, its tilt towards the sun, and the way it wobbles through time. And we can plot these changes through time and look at sediment cores and ice cores and see that the ice caps, the continental ice sheets, waxed and waned in direct relationship with these orbital forcing parameters. One thing we didn't understand is that when we had times of deglaciation, they seemed to happen faster and sharper in a time series record. Right, and we refer to that as climate sensitivity. And for a long time we wondered why that continued to occur cycle over cycle in all the records that we would find from the seafloor and again from ice core records. And recently, within about the last 6 to 7 years, there's a hypothesis that as the ice sheets retract on the poles and over the continents, they actually cause an isostatic shift or in the crust that actually also affects the mantle and results in higher levels of volcanism associated with times of deglaciation. So the ice actually retreating from the continents results in increased rates of volcanism globally that increase the amount of carbon dioxide and increase the warming. So the different spheres of the Earth, the biosphere, the cryosphere, the lithosphere, are intimately related, and they balance each other out over geologic time in a truly miraculous way. And it's rocks that tell us these stories and really tell us about the intertwining of these spheres over time and how that makes our planet such a wonderful and spectacular place. So this is the kind of work that we continue when we're out here. We look for time series data as well as observing things in real time, looking at various genetic signatures that we can also look at, you know, how they've evolved through time. Again, the stories that are that the planet tells us that have gone on this planet over geologic time are absolutely amazing.
I knew there was positive feedback through ocean warming, releasing more CO2 into the atmosphere, but I did not know there was more volcanic activity as the glaciers
Right,
retreat.
and this is the current kind of cutting edge of climate science. So there are many people at different research labs at Lamont Doherty Earth Observatory and in Washington, and that are really trying to examine the timing between increased volcanic activity and climatic changes to test this hypothesis robustly on a global and regional scale.
And so how is the work that we're doing, that you're doing on this cruise here, hoping to play into either supporting or disproving that hypothesis?
So for me right now, I don't have any time series of intraplate volcanic activity, but it is something that I'm looking to do. So because when you date rocks on the seafloor, they're so precious and getting them is so rare, you can't actually do a time series of how that volcano evolved through its lifespan. So it would be really difficult to get various, like dozens of samples from a seamount from its base to its peak that should tell you about how long it lived and when its most active time of its life was. So these are hard to do on the seafloor, but I do also date subaerial islands like the island of Tahiti and its relationship and how it records the last geomagnetic reversal that we call the Bruns-Maruyama reversal. And we can start examining the rate of volcanism by getting dates of each flow and seeing if we can reconstruct a change in basically volume per time associated with a climate cycle. I would imagine that would be something that it will take a long time to do, but will be in the future, something that future scientists propose more and more often.
So we're collecting rocks to figure out when these volcanoes were erupting. The ones that we are diving on volcanoes that are not erupting now, but they were erupting at some time in the past, and we are trying to figure out exactly when these were active. And what's your best scientific estimate right now before we have actually collected the rocks and done the sampling?
I would guess that they're in between 70 and 90 million years old, and that they would have an age progressive pattern with the youngest seamounts being in the south and the older seamounts being in the north. And that would, if that is true, that is evidence that supports that they are a plume-derived age-progressive seamount chain. And so one of the reasons why we study intraplate volcanism, so volcanoes that form in the plate, in the oceanic plate, is that when we reconstruct these age-progressive seamount tracks, we actually learn about how the plate moved through geologic time, how fast the plate was moving, its orientation, its direction, when it changed direction. And then we can begin to hypothesize why those things happened, why it sped up, why it slowed down, and why it changed orientation. The more information we have about the more age-progressive seamounts that chains that we date, the more information we have to constrain that reconstruction.
All right, thanks for that explanation.
Just looking at this interesting ridge that runs down from the Hawaiian Ridge down to Ha'eo here. Ha'eo. Maybe some connectivity between ancient seamount and newer ridge.
We also, and it has been proposed in a paper by Brent Dalrymple, who's one of the fathers of geochronology, actually started dating rocks in the 1960s. He had a paper where he dated some of these seamounts. I think some of them that were passing really close by, I think in the 1970s or 1980s, and they hypothesized that a lot of the Hawaiian Ridge volcanoes that are seamounts that are larger than some of them that are adjacent to them are actually overprinting ancient seamounts. So under these larger volcanoes, you might have some older volcanoes. And the plumes, the Hawaiian plume might occupy planes of weakness and cover up those smaller seamounts completely. And all you have left is the larger, younger seamount basically existing and covering up that older material. And so that is one of the things we also like to test. But again, we're limited on the amount of samples that we can get from these underwater seamounts. It's very, these samples are quite precious when we actually do get them.
All right, so that kind of sums up some of our geological tectonic talkers goals for this
tectonic talkers
for this cruise.
Living up to the reputation.
We're also getting questions in from viewers that are watching our work here in the control van about why we are masking up when we're all here on a ship together. And we are all here together. We've been on board. We've been underway since Monday. Emil, do you want to address that question as our leader here?
I'm sorry, I was listening to Steve for a moment. What was the
sure.
question?
So the question is, why are we masking when we're here in a bubble on the ship, and we've been here since Monday, and some viewers are interested to know what's up with that.
Right, we recognize that breakthrough cases are always a possibility. A lot of us had long flights to come out here. There's an incubation period, typically 3 to 5 days for COVID, but it could be a day or two longer. For some, everybody's immune system is a little different. So we're just exercising a lot of caution because we need everybody out here. We can't lose a member. If we had an outbreak on the ship, that could have a big effect on our expedition. So it's a small price to pay for mission success. Yeah.
Absolutely.
And we also had a test before we got on our plane, and we have a test before we got into the ship, because we're taking it very seriously.
Absolutely. And we do run 3 full shifts a day, so everybody has a role, and plus we have a lot of support crew, and everybody's job is super important, so safety first.
Yeah, so after tomorrow, we will be our own pod, and we'll be mask-free for the remainder of the expedition.
Because we'll have been past the period of incubation.
Yeah.
Thanks for that question. Thanks for your observation. It's interesting that you can see us here. If you have questions, you can enter them in the box on our website, nautiluslive.org. We are descending to a depth of 2,600 meters, and we are not quite halfway there yet. So we still have at least an hour to go until we reach the ocean floor. And we're just observing the water column. Occasionally we see a very small critter drift past, but you never know what we'll encounter on the way down or once we get there. Not sure if our pilots are on SPL, but we have a question coming in for you.
Got a little bit of training going on up in the front row.
Yeah, we'll give them some time.
So those the glaciation events being influenced by the orbital cycles, it looks like that kicks in once you have ice on a pole. Once you're in an ice age, the natural state of things on Earth, for 85% of Earth's history, it's been greenhouse conditions, no ice. So the ocean circulation and plate tectonics and resulting volcanism, but also ocean circulation, isolating one pole or another, or bringing more humidity to the Arctic or Antarctic or another, affects the transition from greenhouse to icehouse.
We also had the famous snowball Earth.
Yeah.
Where we had the entire Earth covered in ice all the way down to the equator. I think that is about 650 million years ago, but I'm not sure if that's the right time.
I think it might be more like 2 billion, but
is it? Okay.
Yeah, it was just way back.
Way back. I think there was 2 times, I think, that we had an icehouse world, I believe.
So, yeah, I had mentioned earlier ice ages, but causing marine terraces, it's really glaciation events during an ice age. Yeah, at least 2 occasions.
Oh, it is 2 occasions I saw, yeah.
Apparently, yeah. I'll do a little fact checking here.
Well, I don't know if anybody from my class, I am a professor at California State University, Long Beach, and this semester I'm teaching SED-Strat to some wonderful and brilliant and students that are just packed full of potential. I don't know if any of them are listening, but maybe they'll hear this in spirit. Go SED-Strat class, go SED-Strat class.
Well, I'm sure if they're listening, they'll give you a shout out by entering something in the chat there on nautiluslive.org. We do see the questions. They're not showing live anywhere. Someone's asking where can they see the chat. That's just for us. So we're seeing it here in the control van, and it is nice. Occasionally we get little shout outs from folks who we know far and wide. So
yeah,
it's pretty exciting to be here and to be able to share all of this with you. Live, you are seeing what we are seeing when we are seeing it, and we are here to bring it to you.
Yeah. They're grown adults because they're attending college, but I still refer to them as my brilliant pumpkins.
Of course,
So
of
hopefully
course.
a brilliant pumpkin will show up on the screen.
And what was the subject matter and name of your class?
Well, I'm teaching sediments and stratigraphy, so sediment structures and stratigraphy.
And what's stratigraphy mean?
The study of sediments through time associated with different geologic or earth events. A lot of those are these climatic events that we're talking about here, or the opening and closing of a tectonic basin. So looking at sequences of sediments through time and as they record varying depositional environments to reconstruct the geologic past.
By the way, you are correct, Andrea. Between 700 and 600 million years ago, 2 events.
Oh, I got it right.
Hey, there you go.
Sometimes it happens.
It's almost like you're a professor or something.
Yeah.
I remember the primary scientist who hypothesized about the ice house world and snowball Earth. He came to give a talk at the school I was attending for my PhD. And at the end of the talk, he had basically described the, I don't know, 10 or 15, maybe even 20 years that he'd been proposing this hypothesis and getting a lot of feedback that was not in support of his hypothesis. And he left it with a quote that says, well, you know science, it moves forward one funeral at a time.
Oh, wow.
Yeah.
Okay, that's a bit dark.
Yeah, that's a bit dark. That means he'd been fighting that battle for so long.
That's kind of cold.
Yeah, oh yeah.
So we're getting a question from a viewer here about the most exciting thing that we've seen on the expedition so far. Now, I'm going to probably rule out the sperm whales that we saw today because that was technically from the deck of the ship and not from the ROVs. So highlights that we have seen so far on this. Stephen, I know you said that the sponge we saw earlier today was maybe the best sponge you've ever seen. I don't know if it was just the midnight to 4 a.m. shift talking, but...
No, I really thought those sponges were beautiful.
So is that your highlight so far?
Yes.
Okay. Those will definitely make some sort of highlight reel, I'm sure. And who knows, we'll probably see some similar ones on this one.
I also loved the sponges, but I would say one of the highlights was just the beginning of the first dive, that we had made it. And we have, you know, gotten past this lockdown that we had, and we're back to some type of semblance of reality that we knew before, and that we were back doing science and exploration. So yeah, maybe the sponges in the first couple seconds of the first dive.
I never get tired of the sponges and corals, but I've wanted to see a manganese nodules for so long, so I was really pretty psyched to see so many of them yesterday. I was picturing potato size, not these little M&Ms and marbles, and but pretty cool to see them at the depths. We were at about 2,800 or so.
Yeah.
Came across those.
Bridge, Nav. Can we move 50 meters, bearing 270? Thank you.
So you just heard our navigator calling in a ship move to the bridge. They work very closely. The ship and the 2 ROVs have to do a very delicate dance. They are tethered together, so they're in constant communication. That's what you just heard from our navigator. What about you, Sarah? Any highlights so far?
Sponge was pretty cool, the Dr. C sponge. And I think just the rocks in general. It's very exciting to see all these pillow basalts and then get to touch them later. It's kind of mind-blowing. So I'm enjoying that in the lab.
Yeah, and for me, I would agree that it was really that first watch. I have been a long time super fan of the Nautilus live stream, and I feel like someone who's watched their favorite TV show for years and then suddenly gets to show up and have a bit part. So it was really emotional to sit that first watch, and I'm keeping my excitement in check, I think. I'm trying. I only squealed that once.
Yeah.
But yeah, it's all been super fantastic. Thank you for your question, Vince.
So there was the first ice age, that the first of 5. The Huronian was 2.4 to 2.2 billion years ago, and that is also considered perhaps the first of several snowball Earth phases.
Really
The
nice.
others being the one you mentioned, the Cryogenian.
So if you're watching on the quad view or on channel 3, you're seeing a live feed of our lab that's here on the ship. This is where all of the samples that are brought up, biological and geological samples, are brought to this lab to be stabilized and processed and sent to scientists around the world to answer these questions about geology, biology, and the biological communities that we're exploring. And on channel 1, you're seeing they're practicing, the pilots are practicing moving the manipulator arm there. So we got a question here from somebody who might be thinking about a career in ocean exploration. They are wondering how we all got to the seats that we sit in. What did people study, and what was the path to doing this deep ocean and ROV work?
We can certainly go into that, but I do want to point out that on the Nautilus Live website, each of the watch teams, the personnel are listed, and you can click on the headshot and see a nice biographical summary of everyone on the team to see how they got here. And you will see non-linear paths.
That's right.
There are many ways to participate and contribute.
Yeah, thanks for that. It is really interesting to talk to everybody. We have 43 people on board, counting the science team and the crew, and no two people are alike. Everybody got here through different paths and life experiences that vary widely. And
yeah, I would say that, so I'm a non-traditional path for sure. I didn't even have a college degree until I was 39 years old. I only had a high school diploma, and I was waiting tables until that time. So at 39 years old, I had a bachelor's degree for the first time in my life. And when I went on to get my PhD, which was not something that was classically done at an age like that, and ended up eventually getting a postdoc at Caltech. So numerically, statistically, that path probably doesn't exist in the statistics so much. So it just shows you that you can do whatever you want to do whenever you want to do it. So if you have a dream of doing something like this, I suggest you 100% follow that dream and plot a course that gives yourself the highest chance of success, and don't give up.
I fully concur. Yeah, my path was in a roundabout way through my naval career as an oceanographer. Dr. Ballard got the Naval Academy midshipmen involved in internships as navigators out here. But as he told the midshipman during a lecture to the entire brigade, all 4,000 midshipmen. He said, do not fear failure, run straight toward it. Stretch yourself, don't worry if you fall short of your target or if your hypothesis is wrong, just get out there, stretch yourself, and yeah, keep your eyes and ears open for opportunities. And if your heart's in it, you'll succeed. Guess I'd have to add, got to be a good team player to succeed in ocean exploration at sea.
Oh, yes, that is true. You should never underestimate the power of empathy, kindness, and compassion. They are 3 characteristics that bring you great leadership abilities and the ability to touch other people's lives in the most profound ways.
Thank you both for those answers. Those were like way more meaningful than just reading a resume. So thank you. If you want the resume, you can get that online at nautiluslive.org, as Emil said, for all of our team members. And it's not just scientists that are here. We have people who specialize in all sorts of different areas of expertise. And you can go check out there some of the types of work that we're doing here shipboard. So if Dan or Gabby's on SPL, we have a very astute viewer noticing that the manipulator arm on Herc looks different than it did on the last dive.
That is astute.
That is astute.
And correct.
Can we talk a little bit about what we're seeing there on the manipulator arm and how it's different than what we've been seeing so far this season? You're not on SPL?
Yeah, the manipulator arm on the starboard side of Herc is slightly different. We put a new end effector on, a new set of jaws, basically. And there's a few different types of jaws you can have. Last dive we had the parallel jaws, where the 2 sides of the jaws always come together. The 2 sides of the jaws are always parallel. And those are good sort of for one set of tasks. This set of jaws is called the coral cutters, and they actually have some scissors built in. And they have these, so they're a much longer set of jaws. They have 2 little pieces of Tygon tubing for gripping coral. And then they have 2 blades that come together and help chop the little piece of coral off so that we can sample coral. They're kind of much longer than the other types of jaws that we use and a little bit more unwieldy. So we tend to only put them on when we're specifically going on coral sampling dives.
Awesome. Thank you for that. So no more full beans with these jaws.
Yeah, we can definitely full beans, but it's a lot more, for me at least, it's a lot clumsier.
Well, we're looking forward to seeing you sample some biology here on this dive. The other jaws we were using mostly to pick up rocks and squeeze them to see if they crumbled or not. But on this dive, I think we're hoping to see and perhaps sample some interesting biology. So we're getting some more questions about the nodules, about how long we think those take to form.
They take a very long time to form, on the order of millions of years. There has been some dating of the nodules from the inside to the outside because they precipitate consensually over the, basically they precipitate over the roundness of them, each layer, right, throughout time, but concentrically, but it's over very long time scales, millions of years. So somebody has dated them using certain isotopes, and they, I think some of the ages were 3 to 6 million years on the ones they dated that came off the coast of Chile.
But they formed after the volcano stopped erupting, which we think was around 70 to 90 million years ago. So since that time, all of these manganese nodules would have formed. Is that what we think?
Right. So probably in that activity would have not been a good environment for manganese nodules to form. So yes, they probably formed after the formation of the volcanic structure itself.
Great question. Hopefully those samples that we took might help to contribute to that understanding of their their timeline.
They will go to a scientist, Kira, that's at the USGS in Santa Cruz, and that is her specialty, manganese crust.
I have read that they're deposited at just a few millimeters per million years.
Yeah, so very, very slow. And so Kira once described, I said, why are they so rich in these heavy metals that are precious? And she said, because they take so long to form that they can accumulate these precious metals, even though those metals are relatively low concentration in the water column.
And then, yeah, one of the open questions is what role do microbes play in that?
Exactly.
Position?
That's another great example of different spheres intersecting, like we were talking about earlier with the climate. The intersection between biology and geology in the deep ocean is another focus of our exploration here, not just the dating of the volcanoes, but this interplay between biological life and the geologic features is another area of study that we're focusing on. And then finally, we have some biological goals, and this is a question that just came up in the chat about, do we think we might find a new species of coral or sponge on this expedition? And if so, what's the process for identifying and naming a new species?
Where is Steve?
I think Chris Kelly is listening now, and he definitely hopes we find a new sponge species or a new coral species. And if we do, and the conditions are correct, and we have the correct number of them that we see, we can take a sample of them so they can be identified clearly and be added to the list of new species. I know that he examines these things under a microscope and looks at the tissue and has other people weigh in on their opinion of different new species. But that is one of the goals here, is to identify any new or rare species that live in the monument, to make sure that the value of the monument is accurately represented when policy and decisions are made. So when we know more about the diversity in the monument and its value as a rare and special place, we can make more informed and better decisions about the policy and things that impact this region.
Some cases, it'll requires genetic studies to determine whether you've got a new species on your hand. So visual ID isn't quite enough in some cases.
And this process takes a very long time, right? Even if we collect a species that we believe is new to science, it's not like we get to declare it right then. There are lots of testing and documentation and publication that has to go before that. So thanks for your question.
I would not be surprised.
Yeah, we find new species, I believe, on the last cruise. I think we found at least 7 new species. I'm sure Chris will correct me, but 2 of those were squat lobsters, if I remember correctly. So it's not uncommon for us to see new species down here, because exploration of the deep ocean biosphere is not very common.
The last cruise in this area in the...
Yeah, in 2018.
Uh-huh.
I would not be surprised, but I would be delighted.
What is the current depth?
We are at 18.